Oh, yeah, we didn't quite get around to talking about those. It was kind of, you had to understand the zeros to understand this. But 53 says, using only algebra, find a cubic function with the given zeros and support by graphing your answer. And so I have 3, -4, and 6. And what do you know about zeros? Okay, algebraically, as far as the equation itself goes. Okay, if I have, let's think about the ones prior to this. So, like number 41 or 42 was 7 times x minus 3 squared times x plus 5 to the fourth. What do you know about the zeros there? 3 and -5. So how could I use this and apply it here? Switch the signs and make factors out of them. Do you agree? Would this be, what did it say, a cubic function? Is this a cubic? Does it have the zeros 3, -4, and 6? I don't even have to multiply it out because it didn't ask it for me in standard form. It said support graphically, so if I want to go graphically, I could come here and I could type, all right, well, let's see, what did I say? X minus 3, X plus 6, no, minus 6. Thank you. And if you look at the graph, it does cross at -4, -4, 3, and 6. And then you said 55. It's the same thing. It doesn't matter that it's square root. It would still x minus root 3, x plus root 3, x minus 4. Anything else? Everybody good? Going once? Going twice? You knew it was coming. You need a pencil and a calculator. It's actually been 2 sections, not 1. Yeah. I think I might have read. I shouldn't ask if I read. You're on a sticky note on my desk, and then 2 other people. Something's wrong with my grade book right now. I can't figure it out. I got a little error message on it. I gotta ask it. No way. You need to know the end behavior. You need to look at the graph and see, because you got the calculator. What's your question? I use your calculator. My other calculator's dead, and I just got to go on mine. All right, we're not going to take, this is a super easy one. It should not take you long at all. I should have put the box problem on there now that I think about it, but I shouldn't. No, I think the picture's fine. I have your other one graded. I have seen in the grade book that something's wrong with my grade book, and I can show you. I'll give it back to you so you have it. The grade book working. here in junior leadership that won't be here tomorrow? But nobody in here. There's several in third block. Yes, ma'am. It's the biggest exponent of the entire thing. That's fine. You knew that it couldn't be negative. Let's go. Yes, she's talking about on the one that asked if it was a monomial function, and yeah, it can be. I don't know. I hope it's good. Why you think it's gonna help you? I think so too. Well, see, there's 5 questions, so yeah. I'll have to see. What do you mean the 0 on the back? The zeros? There were 2 on the back. Oh, there were 3. Even the algebraic is the very last one. You didn't put something in right with your graph.
There was one thing about I mean, I understand like why you have that. How does that work? How does the graph not line up with that?
I'm fixing to show you. Yeah. Yes. Direct. It was direct. Direct. Remember, if the variable's in the bottom, if you divide, if you just have negative exponent. The other one wasn't. It wasn't a monomial. Yeah. Okay, feel better, right? All right. Let's talk about zeros of polynomials. This is gonna feel like a recap of Algebra 2. I'm sorry. I feel like I say that every day. This is a recap of Algebra 2. But we'll start out with kind of reviewing the Algebra 2 part of it, and then we'll get into the more difficult part of it probably tomorrow. Is that my what? Yeah. Yes, we're gonna do that. I don't even know if we're doing that. I think we're doing that in the next section. Maybe. Do what? I got mixed up. It was my fault. It was the first part of zeros of polynomials. It's actually more like multiplicity is what I ended up going back and renaming it. All right, so we know that whenever we find the zeros of functions that we set the function equal to 0 and we solve. So some things that we may have to do in this process. So before we get into just zeros of polynomials, let's talk about some techniques and some methods that we use so that we can get things factored down, because we know we set factors equal to 0. So the first thing that we do a lot, we'll call this methods. Methods of factoring, maybe we should say. Polynomial long division. Everybody's favorite. Do you remember it? Do you remember it from Algebra 2? It's just long. It's not that it's hard. But now you know. just so that you know, no, I'm not going to do that. All right. I think the easiest thing is to bust into an example, and let's review. If we have 2x to the fourth minus x cubed minus 2 divided by 2x squared plus x plus 1. What goes on the outside of the division sign? I'm going to put a note here. Don't forget your placeholders. The 2x squared plus x plus 1. How about inside? 2x to the fourth minus x cubed. There you go. Yep. Plus 0x squared plus 0x minus 2. If I need to slow down, let me know, because I'm not really going through teaching this. I'm just kind of refreshing you from what we did now. Yes. You need me to for real, for real? I know. That's why I said, are you sure you need me to for real, for real? First step. What do I multiply the first term of the outside by to get the first term of the inside? X squared. Go to where these squareds are, which is here, and write it above there. You want to keep your problem nice and neat, so you want all your same powers lined up as you go through. So this is the powers of 2, so I'll write it above there. It'll just help you keep your answer straight as you go. Now what do? Multiply this through all the way around. Okay, so x squared times 2x squared is the sad part about that is I understood everything you just said, and the answer is yes. X squared times 2x squared is, remember, keep your columns lined up, right? X squared times x, what is it? I mean, yeah, x to the third. And x squared times 1. Now remember, I am subtracting all of this, right? So really this was plus and plus. When you subtract, if you like to change all the signs inside, you can. If you just like to know that you're subtracting each term, so 2x to the fourth minus 2x to the fourth cancels. What is negative x to the third minus x to the third? There you go, negative 2x to the third. And then 0x squared minus x squared, right? Bring down the next term. Do everything all over again. What do you multiply this by to get this? Negative x. So it goes in the x column and multiply around. Is it coming back to you? It's all coming back. It's all coming. Keep going. Brett, what is negative x times 2x squared? That is correct. Negative x times x and negative x times 1. Remember, I'm subtracting all of this. Negative 2x cubed minus negative 2x cubed cancels. Negative x squared minus negative x squared cancels. 0x minus negative x. And we do the process again. But wait, I can't multiply that by anything to give me this. So what does that tell me? This is my remainder. What do I do with a remainder? I add it, and I put x minus 2 over what's on the outside. Yes. So in fact, your book lays it out for you in sophisticated terms. If I have f of x and I divide it by d of x, okay, what I get is q of x. Can you think about what these variables might stand for? Quotient. That's right. Quotient plus remainder. What would it go over? D of x. What you divide by is what it goes over here. So quotient and remainder. Y'all okay? What was what? Yeah. No, so this was 2x to the fourth minus x cubed minus 2 over 2x squared plus x plus 1. So what's in front in the division problem? Yes. Is that what you just said? But what's in the bottom, what's in the denominator stays in the denominator. Does that make sense? Yes. Yes. Yeah. Does that make sense? Okay. Everybody good? Let's talk about the remainder theorem a minute then. See if you can figure it out on your own. If I had f of x, yeah. What's the remainder here? 3x to the second. Now, first off, should you do long division here? Why? How do you know you can use synthetic there? When you divide by x plus a number or x minus a number, and most of the time we call that number k for a constant. So x plus k or x minus k. You can't have any coefficients or any exponents on x, but as long as you're dividing by one of those, you can definitely use synthetic division. So what I want you to do is divide this and tell me what the remainder is. Huh? 2 on the outside. I'll set it up for you. It's the opposite sign on the outside. Y'all don't remember synthetic? Do I need to take a minute and review synthetic? This is the opposite sign here, And these are all the coefficients. So 3, 7, and negative 20. Now you have to remember placeholders here. You drop it, bless you, multiply and add, multiply and add. It goes remainder, constant, x, and then we would keep moving up. So this would equal, this division problem here, would equal 3x plus 13 plus 6 over x minus 2. Now, while we're right here, I want you to do something for me. What is f of 2? See if you can find that. What is f of 2? If you plug 2 in for f, what do you get? You can do it. The original equation. Same problem. I'm trying to get you to draw a conclusion here. I'm setting you up for something. Okay, not on what you get when you divide. If f of x is 3x squared plus 7x minus 20, what is f of 2? No, f of x is this, and I want to divide it by x minus 2. I'm sorry if that was confusing. Keep that in mind. And I want you to take this same f of x and divide it by x plus 1. So let's now do f of x divided by x plus 1, and tell me what you get. Do this one on your own. Did y'all get it? Don't forget your placeholders here. That's really important if you need them. All right, I got 3, negative 3, 4, negative 4. What'd you get for your remainder? Negative 24. What answer are you talking about? So you plugged in, you did f of negative 1. I'm glad you did that, Kirsten, because that was going to be the next thing I asked you to do, is to find f of negative 1. And Kirsten said, but wait, I got the same thing, but I didn't divide. So guess what? This is called the remainder theorem. The remainder theorem says, I'm going to put some variables in here. If you divide f of x by x minus k, or x plus k, Okay. In this case, we'll leave it x minus k because remember we're doing the opposite sign whenever we plug in. Then f of k is always the remainder. In other words, I could do what Kirsten did, and I could just plug in if I want to know my remainder to know whether or not I need to divide or what I need to do from that point. But I can plug in without doing the whole division process. Does that make sense? Sometimes you don't need it, which is crazy enough. Sometimes you just want to know if it has a remainder. Yes, you're absolutely right, Alex. This only works when you can set up for synthetic, okay? So whenever it's x minus k or x plus k. So let's do one more example, and then I got one more thing to show you. Yep. Yes. Okay. Thank you for your honesty. So the directions say use the remainder theorem to find the remainder when f of x is divided by x minus k. So what I'm dividing by is x minus 2. What is my remainder? Which one do you think would go? It's the opposite sign of the factor like this. So positive 2. What you get? If you divide it synthetically, do you get the same thing? Yes. Make sense? All right, let's talk about the factor theorem. I know, contain your excitement, Brett, please. This is so interesting. I'm glad you asked that, Kirsten. If it doesn't have a remainder, okay, so let's say if I get a remainder of 0, what does that tell me that I have actually divided by? A factor. And if it's a factor, all right, so if I get a remainder of a 0, that means that this means you divided by a factor. And then some of you have already jumped ahead and said, wait, that means it's a 0. And you're absolutely right, because a factor gives you a 0, right? How does a factor give you a 0? If I divide it by x plus 2 and I got a remainder of 0, that means that x equals negative 2 is a 0, right? So what does this have to do with zeros of polynomials? Well, if I get no remainder, then I've gotten a factor, which then gives me a 0. Does that make sense? And in fact, that is the factor theorem. It says theorem. X minus k is a factor of f of x if, you have any guesses? How could I say that using that remainder theorem I already talked about? You're exactly right. If f of k is 0. If I plug that in and I get 0, that tells me that I have a factor. It's actually taking something you already know and trying to get it to help you learn something new. Thank you, Brett. Thank you. Let's do one from your homework that looks like this, because I don't want y'all to get on your homework and say that we didn't do any like that. I got one more thing. I know I already said that, but use the factor theorem to determine whether the first polynomial is a factor of the second polynomial. So is x plus 1 a factor of, it's really not. And if I'm using the factor theorem, that means I'm trying to figure out, what am I going to plug in? Negative 1, because I want the opposite sign. Does f of negative 1 equal 0? It's a yes or no question. Plug it in and see if you get 0. If you do, it's yes, it is a factor. If it's no, then, if it's not 0, then it's no, it's not a factor. Bless you. Some of y'all are really typing fast on those little calculators. Well, I hear click. Brett, on the other hand, thank you. What's f of negative 1? Is it a factor? Did y'all get 0? I was going to say, I don't think you should. So do 2 times negative 1 to the 10th minus negative 1 to the 10th. Plugging negative 1 in there. Make sure your -1 in the front is in parentheses. You're checking to see if it equals 0. So if it equals 0, it's a factor. If it doesn't equal 0, it's not a factor. So this was not a factor because it did not equal. Somebody asked me to go back a second, Brett. This is the graph of this function. Use the graph to guess possible linear factors of f of x and then completely factor with synthetic division. In other words, factor this completely. What in the world does that mean? Okay, so we can look at the graph and say we know that this is a 0 and this one's kind of hard. I can't get an exact value for that. But this is at, looks like it's x equals 3 and x equals -2. What do you know about zeros? Okay, algebraically, what do you know about zeros? They're factors. They're factors. So x plus 2 should be a factor and x minus 3 should be a factor. How can I tell if it's a factor? Plug it in and see, right? See if the remainder's 0. So I'm going to synthetically divide this one this time because they asked me to factor it completely. Okay? And remember, and I'm going to just do the -2 here. 5, -12, -23, and 42. I could do synthetic division or I could do f of -2. Either one would be fine, but since I'm asked to factor this one completely, I'm going to go ahead and divide it so I can get the other kind of part of the problem here. -22, that would be 44. 21. Is it a factor? Yes. So now let's think about what we know when we divide something, because it asked me, it gave me a starting point, basically, is what it did. It gave me a starting point of what I could use to divide. And it said x, okay, so x plus 2 is a factor. Remember, my original equation was 5x cubed minus 12x squared minus 23x plus 42. What do I need to multiply x plus 2 by to still make it be the same thing? That's exactly right. Does that make sense? Okay, so if you wanted to then take this and synthetically divide, you certainly could, if that's easier for you. The other option there is to factor what's left, if you can. But that's a great idea, Kishran. I wouldn't have even thought to do that to start with. I would have just not shown the factoring, but that's definitely something you could do because it is a 0.